will be reflected, let's say, from here, here.
Yeah.
Is that the question?
Yes, yes.
Perfect. So replacing x with negative x will do that.
I thought...
In other words, replacing 2 by negative 2 will reflect the graph with respect to the y-axis.
I got you.
So I gave an example, and I'll give it again, which is this. The square root of x and g of x equals the square root of negative x. See? The negative is not outside. Obviously, it's a transformation on x because the negative symbol touches x, right?
Oh, when it's outside of it, like...
When it's outside, let me present all of them again. So when it's outside, it does not touch x, so this is a transformation on y. This represents negative y. So when you graph the square root of x, you have this. When you graph the square root of negative x, you have this. And when you graph negative the square root of x, you will have this. Because all the y values were multiplied by negative 1, all x values were multiplied by negative 1. Does that answer your question, or do you need more examples?
No, that's perfect.
Okay. Anyone else? Other questions? Have you tried anything else? Anything for me? Okay, then let's look at function composition. What is it and why do we need it? Well, I have to say that everything is a function composition in a way or one way or another. So function composition is the fifth way of creating new functions. What do you mean the fifth way? Yeah, I just recycled my papers and we had 4 ways last time. Here are the 4 ways. Adding, subtracting, multiplying, and dividing. So this is the 5th one. And it's not any of the above. Is denoted by F comp G, a circle, tiny circle, not too big and not too small. So this is read F comp G, or the composite of F and G. I can have G comp F. I can have F comp F with itself, and so on and so forth. What does it mean? So let's look at some bubbles. We call them bubbles. So let's suppose I have here x, and I apply the function g to it. Of course, I will get g of x. It's a number. This is a number, this is a function. I apply this function to this number, and I get this number, whatever it is. But let's assume that I continue now. To this number, I will apply a function f. And if I do that, I will get f of this number, f of g of x. So f of g of x is the notation, careful, f comp g. G was the first function, is the closest to x, was the first function applied, and to g of x a second function was applied, and we get f of g of x, which is f comp g. Remember when we talked about the sum, the difference, product, and ratio? What was an important topic that we had to determine when we added, subtracted, multiplied, or divided functions? What was important to know if the functions that were given to us had what? A what? Anyone? If I didn't hear, but I'm assuming you said the common domain. So if those two functions, f and g, did not have a common domain, these functions could not be created. Here, there's no need for common domain here. No need for functions to have a common domain, No need. These two functions, f and g, do not have to have a common domain. However, we may run into a different problem here, which I will, in this class, in the other classes like calculus, pre-calculus, I ask my students to find the domain of the function composition. I will not ask you to find it, but I would like to just explain what the problem could be. What is the problem that we could run into? Again, the same scenario. I have x, g, I get a result, which is an output of g of x, whatever number. I continue the chain. I apply this function f to this number to get f of g of x. Okay. Now, the question is, what could go wrong? And here's what can go wrong. Can anyone tell us what is this? What does this represent for function g? Can anyone say what this is? And then what this is for g? This is the set of values for the input, and this is the set of values for the output. How do we call them? How do we call this set, and how do we call this set? Where we take values for x values for g. How do we call this set? Anyone? We always determine it, so we know where x is defined. So what will this be? How do we call this set for g? Domain. How do we call this set for g? Anyone?
Range.
Thank you very much. But this is range of g. Stay with me, please. What does this set represent for f? What does this set represent for f? Anyone? Is the set of x values for f. What could it be? We know what it is, right? Is the domain of f. So this set has two designations. One is the range of g, and the second one is the domain of f. What could go wrong? F, let's say, may not be defined at 5, but g for 0, g of 0 is 5. I can continue because I cannot apply f to 5. So if I have this situation, let's say 0 goes to 5, but f is not defined at 5. Let's say f of x is 1 over x minus 5. So I applied the g to 0, I got 5, but I cannot plug in 5. So the chain is broken. I cannot continue, I cannot get here. So bottom line is that these two functions do not need a common domain, but they need the range of g to communicate well with the domain of f. If g brings something that f cannot be applied to, then the chain is broken, so adjustments have to be made here. I'm not going to test you on that. I'm not going to ask you to find the domain of function composition. But now we are ready to create some function compositions. So let's take a look. I'm looking on page. You can choose, obviously, at any point in time. Let's start with 60. On page, this is on page, what page is this? 310. 60 on 310. Okay, so it has f of x equals 5x minus 2, and it has g of x negative x squared plus 4x minus 1. It's kind of blurry, but I think it's 4x minus 1. Yes. They're asking us to find f, come g. Find g, come f. Find f, come g of 2. Find g, come f of 2. Fine. Let's do that. And then we'll move on, unless you want more examples, to some graphs. I like to look at some graphs. Okay, ready? So the first question, so part A, let's say, is f, come g of x. I will immediately write the definition, which is f of g of x. Then I will, don't cross it out like that, I'm just making a point. Next step, I have f of, and I replace g of x by all this. Negative x squared plus 4x minus 1. Now, I look at what f is telling me. F really says this. And that's exactly what I'm going to do. I'm going to replace the argument, which now is negative x squared plus 4x minus 1, in here. That's all I need to do, and then multiply by 5 and subtract 2. Let me know if this is not clear, please. So I have 5. Quantity, negative x squared plus 4x minus 1 and minus 2. I have to proceed by simplifying fully. I have to distribute 5, and I get negative 5x squared plus 20x and minus 5 and minus 2. I combine these two and I'm done. So negative 5x squared plus 20x minus 7. What is this? This is the function composition of f and g. G is the inner function and f is the outer function. At some point in time, we talked about the inner and the outer. Well, I guess, no, we didn't do that yet. Sorry. Good. That was part A. I want to jump to part C. Why? Because I have the function. I need to plug in 2. So f, g of 2 is negative 5 times 2 squared plus 20 multiplied by 2 and minus 7. So the calculator that I spilled water on, I hope it works. I babied it. Plus 40 and minus 7, yes, it's still working, is 13. Is there another way of determining this? Yes. Or I can do this. F, g of 2 is the same with f of g of 2. I didn't do this because I already had the function. What's the point? But let's see another way. G of 2. I have to find g of 2. I have to plug in 2 in g. So g of 2 is negative 2 squared plus 4 times 2 minus 1. By the order of operations, I have to square first and then multiply by negative 1. So I get negative 4. 4 times 2 is 8. Minus 1. Negative 4, I do this. This is my preference. Negative 4 minus 1 is negative 5. 8 minus 5 is 3. This piece will be replaced by 3 because it's g of 2. So then I have to find f of 3. No problem. 5 times 3 is 15 minus 2 is 13. Of course, I had to get the same answer. So this is another way of determining f, g of 2. Okay, we completed A and C. Now let's do G and, I'm sorry, B and D. G comp F and G comp F of 2. Okay. I still need this handy. So now G comp F of X by definition is G of F of X. Again, don't cross it out like that. I'm just making a point. I have to replace F of X by 5x minus 2. So this is G of 5x minus 2. Now I'm looking at G. What does G say? This is what G says. G of whatever equals negative whatever squared plus 4 times whatever minus 1. So everywhere I see this box, I'm going to replace it by 5x minus 2, and this is how we know how to read. We discussed that, how to read a function. So negative outside, 5x minus 2 in parentheses squared plus 4 in parentheses, 5x minus 2, and then minus 1. I cannot leave it like this. I have to continue and simplify it fully. Okay. And now I'm waiting for you. I no longer need this. And now I'm waiting for you to tell me what to write. I will copy the negative, and I'm waiting for you to say anything. And how many terms will I have to write? I'll put parentheses, of course. And I need how many terms?
3.
Thank you so much. Can anyone give us those 3 terms, or at least one, the first one?
25x squared.
Very good, thank you very much. Because this is minus, I have to write minus. Multiply these 2 terms and multiply by 2.
1.
Very good. And then plus?
4.
Excellent. This is easy. 20x minus 8 minus 1. Now I have to distribute negative 1 to all 3 terms. Negative 25x squared, but plus 20x and minus 4. And then plus 20x, and this is minus 9. Finally, combine like terms. Negative 25x squared plus 40x. And then, of course, minus 13. I promised that you will see this almost every class. So far, I think I've kept my promise. Okay, finally, I need to find G comp F of 2. And since I have the function, I don't have to reinvent the wheel. And I have negative 25 multiplied by 2 squared, plus 40 multiplied by 2, and minus 13. Be very careful because you have to square first and then multiply by negative 25. So, or put in the calculator, negative 25 multiplied by 4 plus 40 multiplied by 2 and minus 13, and I got negative 33. This is how we determine any function composition. I would like to look at problem 75 through 82 on page, I think it's 311 now. Here it is, 311. And then I would like us to read from these graphs, and then look at word problem and move on. Okay, ready? So 75 through 82. Feel free to choose if you want to. If not, I will.